Today we're looking at section 7.5 on properties of exponents and scientific notation. And looking at, first of all, exponential notation, expressions like b to the n would be an exponential notation. B is called the base, n is called the exponent. And what it means is it means repeated multiplication of the base. For example, 5 to the third means 3 factors of 5, or 5 times 5 times 5, which is 125. So we have several rules of exponents, and the product rule is that we add the exponents. So if we have, for example, x, let me get my pen here working. If we have x squared times x cubed, what we do is we think about what does x squared means. It means x times x. X cubed means 3 factors of x. And so if we count in all, we have 5 factors of x. So the shortcut we can see is to add the 2 and the 3, and we get the 5. So that's what this is saying. If we have a to the m times a to the n, the same base, we add the exponents. Quotient rule is next. Alright, and on the quotient rule, what we find is if we have a to the m divided by a to the n, we can subtract the exponents as long as our base is not equal to 0. We can't divide by 0, so that's the reason for that. So if we have x to the 6th divided by x squared, what happens is we're going to have 6 factors of x in the numerator. See if I can squeeze one more in. And then we'll have 2 in the denominator. And what happens is 2 of those cancel out, and we can see we have 4 factors of x left in the numerator. So x to the 6th divided by x squared is x to the 4th. And we can see the shortcut is to take 6 minus 2 to get 4. If the x to the 6th were in the numerator, or in the denominator, if we had this, we could write that as x to the negative 4, which is also written as 1 over x to the 4th. So we could visualize 6 factors of x in the denominator, 2 in the numerator. Those 2 cancel out, leaving a 1 in the numerator, and 4 factors of x in the denominator. So our negative exponent, and I actually kind of skipped ahead there, means 1 over a to the n. A to the minus n is 1 over a to the n. And again, the base can't be 0. For a 0 exponent, that is defined to be 1. So it's like if you had x squared over x squared. We know that we would get this, and that gives us a 1, and that gives us a 1. So 1 times 1 is 1. And notice 2 minus 2 would give us x to the 0. So x to the 0 is defined to be 1, as long as the base is not 0. Okay, power rules. A to the m raised to the n. If we have x squared cubed, what that means is we have x squared times x squared times x squared. And that gives us 2, 4, 6 factors of x. So we can see the shortcut there is to multiply our exponents. And if we have x times y squared, and we raise that to the second power, we're going to have xy squared times xy squared. And so we're going to get x squared y to the 4th. 2 plus 2 would give us 4 there. So we can see we raise each one of these to the second power. So that's going to be a 1. So that'll give us x squared. And then 2 times 2 will give us the 4. So we're actually using the first rule up here. And similarly, if we have a fraction raised to the m power, it's equivalent to raising the numerator to the m and the denominator to the m power. And again, our base here in the denominator cannot be 0 since we can't divide by 0. Some special rules for negative exponents. What the negative exponent means is take the reciprocal. So if we have, for example, 1 over x to the negative 5, that's equivalent to taking the reciprocal and making it positive, a positive exponent. It would be x to the 5th. If you have x to the negative 2 over y to the negative 3, we can invert these and make the exponent positive. And that's basically what the second one is saying. And a to the minus m we talked about over here is 1 over a to the n. All they've done is just simply put the exponent on the outside there. And if we have a fraction like 2/3, I'm going to cross that out. I think the page number might be wrong. 2/3 to the negative 3 would be 3/2 to the positive 3, which would be 27 over 8. So we raise each one of those to the third power. Now, scientific notation is where we write our number as a number, a, which is between 1 and 10, including the 1 but not the 10, times the power of 10. And our calculators, if our numbers get very large or very, very small, will automatically switch over to scientific notation. And the way you'll know is it'll have an E and then it'll give you a number, like it might give you 5.60000, and then it'll give you E negative 6 would be an example of how it would express this first one that we have here. So that would be scientific notation on your calculator. So notice what we're doing is if we're starting with this decimal number and we want to write it in scientific, we take the non-zero part and we place the decimal so we have a number between 1 and 10, including the 1 but not the 10. We did the same thing here. Here's the non-zero part. You got to include the zeros that are in between. So the only place to put the decimal is right there. Okay, let me see if I can get the dot down here below. Alright, and so then we have to figure out what power of 10 will place the decimal point correctly. Well, here we need to move it 2, 4, 6 places to the left. To the left is negative. We want a negative exponent. And here we want to move it 2, 4, 6, 7 places to the right. And we can see we use a positive exponent there. So scientific notation, once you understand what it is relatively simple. And I think that next page is blank. Okay, so next you should watch the sample problems for this section.